Alright guys, this is Miss Godfrey, and today we're going to be talking about independent and dependent events in your probability unit. My first time doing a video, so y'all just bear with me, I might mess up a little bit. But anyway, independent and dependent events. So the first thing we're going to do is today we're going to talk about the independent events. And then tomorrow I'm going to do another video where we're going to do dependent. So even though this paper has dependent events on it as well on the back, we're only going to be talking about independent events today. So first of all, if a person is independent, you kind of think of them as a person that doesn't really depend on a lot of people, right? So they can kind of do things independently. If you do independent work, you're usually working by yourself. So you're not dependent upon someone else. So in probability, independent events are events. When I say events, like I'm saying if we use things like we've talked about in the basic probability, like we toss a coin or we spin a spinner, those would be independent events. So events that do not affect each other. So for example, just like I said before, spinning a spinner. So just like this spinner down here, it doesn't have colors on it yet. We'll talk about that in a second. But spinning a spinner, if I spin a spinner one time, and then I spin it a second time, which would be the second event, what I spun on the first event is not going to affect what happened on the second event. So this would be an example of an independent event. One event does not depend on the other. So spinning a spinner. Another one would be tossing a coin. So if I toss a coin and I get tails, if I toss it again, I have the same chance of getting heads or tails. Like what I tossed the first time is not affecting what is going to happen the second time. So again, that's an independent event. So you first have to determine when you come to a problem if you are dealing with an independent event or a dependent event. And then it's going to ask you to find the probability of an independent event. So again, we're going to be finding out, like in the first event, what if it affects the other one. If it doesn't, if it's independent, it's not going to affect the other one. So what this stands for here is the probability that event A and event B is going to happen. So what you do is you take the probability of event A happening. So you can see like this is event number 1, this is event number 2. So we're going to take the probability of the first event happening and we're going to multiply it times the probability of the second event happening. So let's just go right into this problem. This might make a little more sense. So on here, I don't have the color. So we're just going to kind of, I believe that, yeah, it starts asking us down here about the color. So what we're going to do is write in, like this one should be blue. And this is green. This is red. This one's blue. This one's green. This one's blue. This one's green. And this one's red. Okay? So when we go down here and talk about the colors, we can see what we're talking about. So the first question is saying, okay, these are definitely independent events because I'm spinning a spinner, which means if I spin it one time, it's not going to have any effect on what's going to happen the second time. So we're good there. So we are dealing with independent events. So now it's asking us to find the probability of spinning a 4. So that's my first event. And then spinning a 4 again. So that would be my second event. So this would be like A and this would be like B. So I first want to find the probability of spinning a 4. So how many times on my spinner can I spin a 4? So the probability of that happening is going to be 3 times out of how many total sections we have in the spinner, which would be 8. So there's a probability that I would spin a 4 3 out of 8 times. And we're going to multiply that probability times then the second event, the spinning a 4 again, which is the same probability because it's not affecting the first event or the first event is not affecting the second event, independent. So again, I'm going to have 3 out of an 8 chance of getting a 4 the second time. So then we just take those two fractions, and just a review of how to multiply fractions. We just multiply numerator times numerator, which is 9, and denominator times the denominator, which is 64. And then in your calculator, you're just going to change that fraction to a decimal. So in your calculator, you're just going to put 9 divided by 64. And that's going to give you a decimal of 0.14. So to change the decimal to a percent, you're going to move it the decimal 2 places to the right. So that's going to give you 14%. So what that's saying is you have a 14% chance of probability of spinning a spinner with a 4 and then spinning it for a second time. Okay. All right, number 2, or B, says, okay, what's the probability of spinning a 1 and then spinning a 2? So again, this is event A, this is event B. Again, they're independent. So probability of spinning a 1. So again, I have 1, 2, 3, 4 ones out of the total sections of 8. So the probability of spinning a 1 is going to be 4 out of 8. And then what's the probability of spinning a 2? There's only 1 2. So that's 1 out of 8. So 1, 8. And you could reduce this fraction if you know that 4 out of 8 is 1/2. You could do that. Or you could just multiply them across either way. So 4 out of 64, which is the same thing as like 1/16 if you would rather reduce the fraction before you put it in your calculator. Either way, whether you do 4 divided by 64 or 1 divided by 16, you're going to get 6.3%. Okay, so again, it would have in the calculator, you would have just put in 1 divided by 16. Again, you're going to get a decimal. You move the decimal 2 places to the right, which is going to give you 6.25. Okay, which I rounded up to the nearest tenth. It didn't really tell me in the directions to round to the tenth. I just kind of chose to do that. So if you put 6.25%, you're not wrong. Okay, just kind of pay attention to the directions or the answers. All right, so here is another example just with the colors. So it says find the probability of spinning a red, then a green, and then a red. So now we have 3 events. So we're just going to take it one event at a time. Again, these are independent of each other. So spinning a red, that's 1, 2 reds. Okay, so 2 out of 8 to spin a red. Then a green. How many greens do I have? 1, 2, 3 greens. So that would be 3 out of 8. And then a red again, which again would be 2 out of 8. So you just multiplied those probabilities together. So that would be 12 out of 512 when you multiply numerators together, denominators together, 512. So then that in your calculator, 12 divided by 5212 is going to give you this amount here, and you're going to move the decimal 2 places to the right, and that's going to give you 2.3%. Okay? All right, now find the probability of spinning a blue and then a blue again. Get your cursor out of the way. Let's see. All right, guys, we're going to go back to do the next one, D. All right, so the probability of spinning a blue and then a blue again. So how many blues? We got 1, 2, 3 blues out of 8. Again, independent. And then blue again, same thing, 3 out of 8. Which is going to give you 9 out of 64, which we already did. If you look up here, we already did that one. So again, we're going to end up with 14%. Okay? Okay, so going down here to number 2, you toss a coin. So again, if you toss a coin one time, it's not going to affect what you're going to get the second time you toss. So again, independent events here. So you're going to toss a coin 3 times. So this would be like event number 1, probably of tossing heads, event number 2, heads again, and then event number 3, getting tails. So tossing a coin to get heads, I'm going to have 1 chance out of 2, right? Heads or tails, that's it. All right, then the second event, to get heads again, 1 out of 2 chance. Okay, then the third event, to get tails, still 1 out of 2. So, excuse me. So again, multiplying straight across, that's going to give you 1/8. And then when you put that in the calculator, move your decimal 2 places to the right, you're going to have 12.5%. Okay. And the last example we're going to do here is talks about the probability of rolling some die or dice. I guess it's the plural would be die. We always talk about that. But anyway, so you're going to roll a 6. What's the probability of rolling a 6 on one number cube? They call it a number cube, same thing. You got only 1 6 on a number cube, numbers 1 through 6 on a number cube. So 1 out of 6 chance of rolling a 6 on the first time, the first event. And then the 6 again, still 1 out of 6 chance, which is going to give you, multiplying across, 1/36. Okay, and then you put that in the calculator, 1 divided by 36, move your decimal 2 places to the right, you're at 2.7%. Okay, so now you're going to do some problems on your own with a different sheet that we're going to give to you just to do some examples, but use this as a guide for your independent practice. Okay, thanks.